Okay, folks, on test corrections, here's what we need to do. You want to get 3 square root of 5 on problem number 1 by the distance formula. I didn't show all of the distance formula. It'd be like 2 minus 5 quantity squared plus, and then negative 2 minus 4, negative 2 minus 4 quantity squared. See, negative 2 minus 4 is negative 6 squared gives you the 36 that's sitting right there. And 2 minus 5 gives you negative 3, but negative 3 squared gives you a positive 9. They're always going to give you positive numbers, right? 9 and 36 makes 45, and then 45 is the same thing as the square root of 9 times the square root of 5, right? Square root of 45 is those two multiplied together. So the square root of 9 is 3. That's how I get the 3 right there, right? That's the same thing as the square root of 9. And we don't know without using a calculator what the square root of 5 is. That's why we leave the square root of 5 alone. The midpoint formula is you add the two x's together and divide by 2. So negative 3, plus 6, right? That's those two numbers right there divided by 2. And then we would have the y's added up, so 8 plus 0 right there divided by 2 gives us those numbers over there. We really needed to see a little bit of algebra work here. I mean, not a lot, but I mean, the fact that you're substituting a 0 in for y to find the x-intercepts, right? That gives us our 2x values, because since we could use Desmos, somebody could just plug this into Desmos, right? And then just look and click on their screen where the x-intercepts are. So that's why I've got this word right here, work. Really on all the problems, we should be showing a little bit of work. So I moved the 9 to the other side by adding 9 to both sides, right? And then you take the square root of both sides. That's where the little plus or minus comes into play, because you could stick a positive 3 in there and square it and get 9, or you could stick negative 3 in for x and get positive 9, right? If I stick a 0 in for x, remember, if we're looking for the y-intercept, we definitely know the x value is 0 right there. So when I stick a 0 in for the x, boy, you have the y value. It's negative 9, right? On number 4, this is what it should look like right here, and I felt like the parentheses, I was trying to stress this in class too, that the parentheses around this negative x are kind of important, because you're really substituting a negative x in wherever you see x. Now in this case, when you have a cubed, you get a negative x cubed. If you had the negative out front, it still would work the same way, but it looks a little funny. It doesn't really look like you're testing about the y-axis if you just have an opposite out in front of your parentheses, okay? Over here, I don't have parentheses around this. I suppose I could, but we're not doing any operations to the y value. You're just substituting a negative y in for y, where the y was. You're substituting negative y in. After you multiply everything by negative 1, you can see we do not have the same exact equation. After I simplify this guy, I do not have the same exact equation. And then over here, same kind of things going on. I'm substituting a negative x in for wherever I see an x. I'm substituting a negative y for wherever I see a y in that equation, and seeing if it comes out to be the same exact thing, and it doesn't. It's a plus 27, not a minus 27. If you graph the function, it would look something like this. It would be going through the y-axis at negative 27 down here, and you can see that if you reflect it over the y-axis, it doesn't land on top of itself. If you reflect it over the x, it doesn't land on top of itself. And if you rotate it about the origin, it would not be the same. This point here would come up here, and so it doesn't work for any of the tests of symmetry that we've done. Down here with the lines, we're going to figure out the slope of that line right there. So how much are we going down? We're going down 2, and we're going over 1. So it's a down 2, positive 1 run. So it's rise over run, right? So I've got rise over run. That's a negative 2 divided by 1. And so I've got a slope of negative 2. And then my y-intercept down here is negative 3. So that's why I've got a negative 3 there and my slope of negative 2. You could put it in point slope form, but not totally necessary. All right, I'll finish the back side of the test on a different video. Thanks for watching.